of all the people applying for a certain job, 75% are qualified and 25% are not. Personnel manager claims that she approves qualified people 85% of the time, and she approves an unqualified person 20% of the time. Find the probability that a certain person is qualified given that they were approved. So it can be hard to tell if the person is qualified or not until they've actually been working there. So that's why you can look at this after the fact and say, okay, well, this person actually was or was not qualified. That's how you can actually get these numbers. But all we know so far is that this person was approved. We're trying to figure out, okay, what's the probability they were actually qualified? Let's write down let's define our events. We're talking about whether they are approved and whether or not they were qualified. So I'm defining E to be the event they were approved, F to be the event they were qualified. All right. So 75% are qualified just going into the job. Without knowing anything else, we have seen that all people applying to this job, there's 75% that are qualified. So the probability of F is 0.75. All right, and 25% are not. That's just the complement. P of F complement equals 0.25. That one's not even really worth writing down. The personnel manager claims that she approves qualified people 85% of the time. So we're saying the probability, if the person is qualified, the probability they are approved is 85%. So the probability they are approved given that they were qualified is 0.85. It's important that when you're reading these conditional probabilities, you're able to write them down in the correct order like this. All right. She approves an unqualified person 20% of the time. So again, she's approving, so we were talking about the probability of E, but given that the person is unqualified, so E given F complement is 0.2. We're trying to find the probability that a certain person is qualified, so probability of F given that they were approved, given E. That's what we're trying to find. And you can see the conditional probabilities are swapped around, and this is how we know that we need to use Bayes' theorem. Each of these, we're just talking about the event or its complement, so it's a pretty standard looking tree. The first branch, it looks like it needs to be starting with F. We get 0.75. Probability of F is 0.75. The probability of F complement would be 0.25. Okay. Up here, the probability of E given F is 0.85. And the probability of, well, I don't know, I might not, actually, yeah, I don't know, I might not need that stuff, I'm just going to leave it. The probability of E given F complement, this is the other number we were given, is 0.2 here. So I'm just focusing on these ones because I'm trying to find the probability of F given E. You can see I just focused on the two branches where E happens. E given F and E given F complement. So that's why I just did these two branches. Multiplying these numbers together to get the branch probability, we get 0.75 times 0.85, which gives us 0.6375. And this one down here, 0.25 times 0.2, which is 0.05. All right, so we have a conditional probability. This is the probability of the intersection of the two events divided by the probability of the condition. So the intersection of the two events, that's this number up here, 0.6375, divided by the probability of E, which we can get through the law of total probability, 0.6375 plus 0.05. So that would be 0.6375 divided by 0.6875 when I add those two numbers together. So it's 0.6375 divided by 0.6875 gives us 0.9273. I'm rounding to 4 decimal places here. So there is approximately a 92% chance, almost a 93% chance, that's part A here, that the person is qualified given that they were approved. Even though only, there's an 85% chance that this person got approved if they were qualified, there's a 93% chance that they were qualified given that they got approved. Alright, let's find the probability that the person is unqualified given that they were not approved. So the probability that they were unqualified, in other words, F complement, given that they were not approved, in other words, E complement. So it looks like on this one, I'm going to need to do F complement intersect E complement divided by the probability of E complement. So I actually need to revisit my tree diagram up here, and I need to finish filling in these places where E complement happens. So let's see, if I went up here, it's a 85% chance. 1 minus 0.85 is 0.15, so that would give me the probability there. And multiplying those together, 0.75 times 0.15 gives me 0.1125. And down here, the probability of E complement given F complement, the probability she's not approved given that she's not qualified, that would be using the complement rule here. There's a 20% chance that you go up, so there's an 80% chance you go down, 1 minus 0.2. And 0.025 times 0.8 gave me 0.2. I could actually go through and verify that the 4 leaves here do sum up to 1, because now I have actually shown the entire tree. I'm not going to do that, but you could. So we're trying to figure out the probability of F complement intersect E complement for the top part here, so let's figure out which branch that is. F complement and E complement, we've gone down on both of those, that's 0.2. And the probability of E complement happened here and here, so that means I would use the law of total probability and add those two up. This is 0.1125, right? Yeah, 0.1125 plus 0.2. So that's, if I add those together, it's 0.2 divided by 0.3125. And then I can actually perform the division here, 0.2 divided by 0.3125, which gives me 0.64. I guess that's exact. So if the person is not approved, there's a 64% chance that they were actually not qualified.